style problems.
Satellite systems. So UG3 learning goal applies to artificial satellites like satellites going around the Earth, natural satellites like the moon, plants going around the sun, debris surrounding a black hole, all that sort of stuff. Okay. So there's a question in your textbook I think that we'll do. We'll do the question number 6, the black hole question, page 147. All right, so it says astronomers have identified a black hole at the center of galaxy M87. From the properties of the light observed, they have measured material at a distance 5.7 times 10 to the 17 meters from the center. So that number is the radius. So we know the radius of motion of this debris. For the center of the black hole, traveling at an estimated speed of 7.5 to 10 to the 5 meters per second. Determine the mass of the black hole. So what is the mass of the black hole? And then they want the ratio of that mass to the sun. And then part C is just okay. All right, so a diagram helps in all cases, even in a case like this. So there's the black hole, the singularity of the black hole, and then here's our bit of matter going around the black hole. So it's moving around the black hole in this orbit. Now, because it's moving in uniform circular motion, there must be some centripetal force. The centripetal force, obviously, in this case, is gravity, and we'll compute it using universal gravitation. So I'm going to put a big G on there, just to remind myself that it's universal gravitation I'm talking about here. And we've got an acceleration vector, which is centripetal, and pointing towards the center of the black hole. Okay, so we're going to apply Newton's second law to our body orbiting the black hole here. So Newton's second law says the sum of the forces equals the mass times the acceleration, which is centripetal in this case. The only force acting on it is the force of gravity. And we'll use universal gravitation to calculate that force. Where M1, we'll just call M the mass of the object, and we'll call big M the mass of the black hole, equals now, since we're doing with uniform circular motion, we have a centripetal acceleration, we can make the substitution v squared over r, speed squared over radius, which is what you discovered at the start of UCM. That's the UCM1 learning goal result. And make that substitution. Get the mass on both sides. So it doesn't matter, you don't need to know the mass of the debris or the material orbiting the black hole. It's not relevant. And we also lose a radius from each side. So the mass of that black hole will be v squared r over g. Is that right? Yeah. Okay, so let's determine if the equation is correct using dimensional analysis. Okay, so on the left side, we've got a mass. The question is that equal to the right side, where we have a length squared over a time squared times a length over, now I've got to remember what g is. What was the unit of g?
It's
Meters. So length cubed over, there's a kilogram in there as well.
kilograms squared.
kilograms times seconds squared.
Okay, so a mass times a time squared. This is up. Okay. All right, let's figure it out though. Okay, so we've got length squared times length is length cubed over time squared on top. On the bottom, we've got length cubed times time squared times mass. Okay, so we can see that those are going to cross out. So we're left with 1 over mass, which is mass. Okay, so dimensional analysis shows that our equation is correct.
Would you want us to do it for?
No, if I ask you to, you have to do it. It's a good tool to have though, because if you get through a lengthy derivation, you can either do a quick dimensional analysis and be done with it, or you can go back and painstakingly follow each step. That takes about a fraction of the time. So it's a good skill to have. If you got, I mean, you don't need to get a lot of time extra on tests, but if you do have that extra minute, you can go through derivations, do a quick dimensional analysis, and double check to see if you got it all right.
So when you get down to that, like the mass equals velocity squared r over g, that's just 7 and solve?
Yeah, because that's all given, right?
Okay.
R and B are given, and G is a constant, which we always have. It's on the formula sheet. So we just input, find the mass. So that's part A. Part B says, what's the ratio of that to the mass of the sun? Well, that would just be the mass of the black hole in relation to the mass of the sun. Just do a ratio. So it's whatever we get there divided by 2 times 10 to the 31, which is the mass of the sun. So that gives you essentially the number of suns, our suns, that make up that black hole. And it could be thousands, it could be millions. There's super massive black holes out there. The final question is, it has been suggested that a dark body is termed better than a black hole. Do you agree? Why or why not? So, what do you think?
Could you answer the question again?
It has been suggested that dark body is a better term than black hole. Do you agree? Why or why not? Why is dark body better than black hole? Well, I guess it could be lumped in with dark matter because you can't see it directly. Dark matter is just matter which we know is there, but you can't doesn't emit light or reflect light. So I guess a black hole would count. I like the term black hole because it's cooler sounding. I mean, I guess perhaps it's not really a hole per se, like it's still an object, it's still a body in space. It's just unobservable because it's got such huge gravity that it sucks back all the light that it emits, right? Or nothing, it doesn't emit light, even though it does through Hawking radiation. Anyways. Okay, don't worry about part C, obviously.
So we like black hole versus
Plus reminds me of that old Disney movie, The Black Hole, which is pretty neat. All right. So that is UG2. So whether it is debris surrounding a black hole or plants going around the sun or moon going around, whatever, it's distracting me. Talking about serious black holes, you're doing like dancing over there. Okay, all right. Are we good then?
Yep.
These are all the same. All these questions are the same.
So that was UG3?
Yeah, and UG3 is really just an extension of UCM, where the centrifugal force is gravity, and you're going to use universal gravitation for that force. That's all it is. Okay, UG4.